Hey guys, welcome to Lesson 20 Notes. We're doing key features of graphs again, since we did so well with them last time. No, but seriously, in all seriousness, we're doing them because we struggled with them so much. So things like x-intercept, y-intercept, in behavior, intervals, notations, extrema, vertex. These are maybe some new ones, but it's really stuff that we're used to. So more of a review than a new lesson, but you know, we got to get this stuff, guys. So this will be on the test, the upcoming test. So let's get right into it. So we know x-intercept is where the graph crosses the x-axis. So it's where the graph crosses the x-axis. The y-intercept, you guessed it, it's where the graph crosses the y-axis. The graph crosses the y-axis. All right, so those aren't too bad. Those are honestly the easiest to remember, so we should definitely know those. In behavior, something maybe a little different, but actually it's just new terminology. So we've been working with this. But with in behavior, you're identifying what happens to y as x approaches. This is infinity, and that's an and symbol, and negative infinity. So in behavior, you're identifying what happens to y as x approaches positive infinity and negative infinity. So intervals are just simply identifying sections of a graph by if they are increasing, decreasing, or constant. Okay, so intervals are identifying sections of a graph by if they are increasing, decreasing, or constant. So I'm going to put out here, let me get this in the screen probably, use parentheses if the point is included. All right, and if it is not included. If the point is not included. Sorry, I just read the notes wrong there. So that means we use brackets, as we know, if the point is included. The point is included. Okay, so that's a little sloppy, but surely you can make it look better than that. A legend or some kind of notifier that this is what we do. So maybe just a reminder. Notations, so we will begin to use builder notation. You don't have to write this. We will begin to use builder notation to identify domain and range. So domain, you do need to write this, is the x, range is the y. Yeah, of course. All right, extrema, we got maximum. Well, that's just your highest point. And we got minimum, your lowest point. So just review there too. So there are some new ones here though. So we got relative maximum is just, well, it's going to be the highest point for a certain section. And then that means relative min or relative minimum is the lowest point for a certain section. Okay, so a lot of writing in math today. Got to really key in on these terms. Vertex is the highest or lowest point. The highest or lowest point. Same thing here. Highest or lowest point, same as vertex. All right, so a couple new things here. I'm sorry, but we do have to switch this up a little bit. X-intercepts and Y-intercepts. So this is a table to kind of figure out, to graphically organize how you're supposed to write these. Okay, so X-intercepts, we're going to start writing them as ordered pair, and also for Y-intercept as an ordered pair. In behavior, we write like X, and this is saying like as X approaches infinity, Y also approaches positive infinity. Do a divider here. Or we could say as X approaches negative infinity, Y approaches positive infinity. So it's talking about the in behavior. Intervals, I think we're getting pretty good at. We've been doing them since we started this year. So increasing is one of those intervals that we'll write. Negative infinity to 5. And this is just an example to show you. There's no graph that we're basing this off of, but this is how you write that. And then decreasing like 5 infinity. So just like that. All right, and finally we got vertex and extrema. These are all as ordered pairs, or as an ordered pair. As an ordered pair. All right, so a lot of notes there, a lot of writing. Hope you got all that down. If you didn't, just go ahead and rewind and make sure you get it down. So let's go and flip over to the first page where we are looking at what type of parent function. Right, it's definitely going to be linear. It's a linear function. Linear are the only ones that will make straight lines. So linear line, straight line. Okay, the parent function for that we know is y equals x. That's how that parent function looks. Okay, so go ahead and figure out the x-intercept and the y-intercept. So hopefully you got 1, 0 for the x-intercept. That's where it crosses the x-axis. So this is the x-axis, crosses at 1. That's why we have an x-intercept of 1, or at 0.10, and a y-intercept at 0, 2. So that's our y-intercept because it's crossing at positive 2. So that point is 0, 2, written as an ordered pair. So you got to start writing them that way, even if you're used to the other way. In behavior, so this is that new thing, kind of. So as this is read as x approaches negative infinity, y approaches, and we know it's going to be infinity or negative infinity, so just look at it real quick. As x approaches negative infinity, which would be which way? Well, it's not this way because that's positive. Those are all positive numbers. So negative infinity would be this way, right, to the left. So as x approaches negative infinity, or as x goes left, as we go left with x, y approaches positive infinity or negative infinity. Well, it's definitely going to be positive. So You see how it's getting closer to higher positive numbers and getting closer to a higher or a positive infinity there? Hopefully so. So if you do, or if you don't, either way, I want you to go ahead and try this. So as x approaches positive infinity, y approaches which form, positive or negative? Yeah, it's definitely negative. Y is approaching negative infinity as x is approaching positive infinity. So I hope that makes that a little more clear. So increasing, is there any spot where this is increasing? Increasing would be going that way. So no. Just put that, no. That's like a nah. Okay, so decreasing would be, we're going to write it like this. Negative infinity to positive infinity. Just like that. Okay, and then nah. You don't have to make that noise. It's okay. So extrema, we got maximum and minimum. Do we have one? Do we have a maximum? These are arrows. These are pointed arrows, so it's going to go on forever. So we don't have a maximum. Oh, we got pointed arrows here, so it's going to go on forever. We don't have a minimum, so nope. And then, so let's see. Let's just go ahead and cross that out. We don't have a vertex because we don't have a highest point. And let's do the domain. Let's bring back in domain and range. I know you all are happy about that. Got to get it though. So the domain for this one, with domain, again, we're talking x. We're talking the x-axis. So we're saying what x's are involved here. So what x's would be in our graph? Well, this isn't going to just this isn't just going to straighten up and all of a sudden decide to go like that. It's going to go continuously forever like that, meaning it's going to go left forever. It's going to go with all of these. It's going to hit -8 as an x. It's going to hit -100. In other words, the domain is all real, okay? Because it does that on this side too. So it's all real numbers for the domain. And same thing for the range. It's not going to just kind of decide to go this way all of a sudden. It's going to keep this route. So that's going to hit 6 and 8 and 100 as a y, and it's going to hit -6 and -8 and -100 as a y. So that means all real numbers for the range. So both of those are all real. All right, good job. Let's do just one more of these and then I'll probably wrap it up. So we got parent function name. Go ahead and put that in there. It's going to be quadratic. Let me straighten this up a little. So we got quadratic. All right. So the parent function equation, what is it? You should have got y equals x squared. Okay. That's the parent function. And then we need to figure out the x-intercept. So looks like it crosses right there. So we write that as -1, 0. And then we have one where it crosses the x-axis right here. So that would be, we'll say and 3, 0. Y-intercept, it looks, we just kind of got to make a judgment call on this. And I'm just going to say it's at about a y of 1.5. So 0, 1.5 is our y-intercept. All right, in behavior, I want you to do the first one. So as x approaches negative infinity, y approaches what? So as x goes, or as we go to the left, y looks like it's going down, right? So this way is negative for y's. If we go down, we go negative. We get more and more negative. So that's why it's approaching negative infinity. And as x approaches positive infinity, or in other words, as it gets bigger, y approaches, well, it's getting smaller. As we go over to the right, our y is going down. So it's going to be approaching negative infinity as well. All right, almost done. We've got these intervals of increasing and decreasing and constant. So increasing is just simply going to be negative infinity to 1. So in other words, it's increasing from all of this negative infinity over here, all the way to an x of 1, which is included. So it kind of rounds out there. And our decreasing is going to be like this. All right. So I hope you can see we do not have a constant here, so nah. We'll mark right there. Extrema, maximum and minimum. Do we have a maximum point? Yeah, we definitely do. Looks like the maximum is just going to be that highest point. So, what, 1, 2 for our maximum? Minimum, meh. You know, so, sorry I didn't have it in the screen there, but 1, 2 for the maximum. Minimum is not there. It doesn't exist. So it wants us to circle. Well, yeah, we have a turning point, a vertex. It's we're not going to do anything else with that. So what would the domain be? Yeah, hopefully you saw that it's all real numbers. So this, again, this is not just going to straighten up. It's going to keep going out. And my lights just went out, so give me a second. All right, the lights will go out in here if you don't move for long enough, and I have not moved, other than my mouth. So, domain all real, and that's because it's going to contain all x values from this way and from this way. So all real numbers for our domain, all x's. Range will be well, let's look. Range is y. It's asking where are our y's held on this graph. So we definitely have a y of 2, and then all the y's are all located on this graph. So all the y's that we're talking about are on here. So are all these y's, are they greater than or less than 2? They're going to be less than, yeah.